So now that we've talked a bit about what completion stage methods do, let's start talking about what completion stage methods are with respect to the API that's provided by Java and the Java Completable Futures framework. And we're going to group these things into subcategories because, number one, you can see there's an awful lot of completion stage methods in general. It's about 2/3 of the overall API of the Completable Future class. And within that completion stage grouping, there are then basically subgroupings based on whether or not the methods are triggered by one or more previous stages. And as you'll see, there's actually 3 different groupings. Some things are completed with a single previous stage. Some things are completed with both of 2 previous stages. And then the final things are completed with either of 2 previous stages. So those are the ways we can further decouple and group these things. And the reason I'm doing this is because it's a little daunting to look at dozens of methods without seeing how they can be structured, because they actually do fit into nice little groups, as we're about to see. So those are the 3 different stages of stages, 3 different groupings of stages: completion of 1 previous stage, both of 2 previous stages, either of 2 previous stages. And you can read more about that in this link here. So let's talk first about the methods that trigger or run their dependent actions when a single previous stage completes. So as shown here, stage 1 runs asynchronously. When it finishes, stage 2 will then run, assuming that there's no exceptions, of course. And here are some of the methods. There's actually a few more, but these are the key ones. And so we're going to take a look at them. So the first one, which you'll be using in your programming assignment, is called thenApply. And it takes a function parameter, and it returns a completable future that will, when finished, give back the result of the function, and it applies the function to the result of the previous stage, whatever that stage may have been. And we'll talk about how this is typically put together in a chain. There's the thenCompose method, which is quite interesting. See, it also takes a function. At first glance, it looks just like thenApply, but what's important to recognize about thenCompose is it returns a completable future that will give the result of the function that does not require nesting. And this may not make any sense yet because we really haven't talked about nesting, but we'll talk about that, and you'll see that thenApply can end up having nested completable functions, which becomes intractable very quickly, whereas thenCompose basically does something akin to flat map, and it flattens out nesting, and it's really cool. And it also applies the function to the result of the previous stage. thenAccept is similar to thenApply, the main difference being that it takes a consumer and it returns a completable future to void. And what that means is there's no return value. So you can wait on it, you can join on it, but it doesn't give you a result. It just does something with a side effect. And the consumer handles the result of the previous stage. And then there's something called thenRun, which doesn't return a value either, and it just runs an action without returning a value. So these are the key single completion stage methods. They complete when a single previous stage has finished. Now, there's also, well, there's the thenApply, thenCompose, thenAccept, and they typically run in the same thread as the previous stage. And then there's also the async versions of all these methods, and they typically run in some other thread in a pool of threads, most commonly the common ForkJoinPool, but it doesn't need to be the ForkJoinPool. So the main difference is these methods, the async versions, will run in some other thread, whereas the ones that are just the methods without the async suffix will typically run in the thread that was doing whatever was before. So if you want a bit more concurrency, then use the async versions. You'll be using the async versions quite a bit in the programming assignment. It cleans up a lot of stuff. The next grouping are methods that will trigger when both of 2 previous stages complete. So you can think of this as something akin to logical conjunction, an and. So both things will complete. And there are not quite as many methods that do this, but they're interesting, some of which you'll be using for the assignment. thenCombine takes a by function, so it takes two parameters, effectively, and it returns a completable future that, when completes, will give you the results of that by function, and it applies the by function to the results of both the previous stages. And that's used typically to join together to previously asynchronous computations that were running in the background. There's one called thenExceptBoth, which takes a by consumer as opposed to a by function, does not return a value, it returns a completable future to void. And again, the by consumer will handle the results of the previous stages. And then finally, there's another one called runAfterBoth, which is going to take a runnable, and it will run an action when both of the previous stages complete. It also does not return a value. As before, there's non-async and async versions of these methods. The third and final grouping of completion stage methods are completion of either of two of previous stages. So this is basically logical disjunction or ORing. Once again, there's a bunch of methods. We'll just take a look at a few of them. The one that is interesting is called applyToEither. We'll show some cool examples of how to use this. I don't think you actually use this in your programming assignment, but it's nice to know about. This is given a function. It returns a completable future with the result of running the function, and it will apply the function to the results of either previous stage. And we'll talk about what happens if something finishes first. It's the one that gets the result back. There's also something called exceptEither, which is very similar, and it takes a consumer and doesn't return a value, and the consumer handles the results of either the previous stage, two stages. And then there's runAfterEither, which is very similar, but it takes a runnable as opposed to a consumer. So these are basically the ways to think about these groupings. And you'll get practice with some of them. Some of them are just fun to know about, and I'll show you some examples here shortly in the next set of slides that illustrate how these things can be applied in practice.